So one of my previous videos, I used this childhood book, the robot book, to try and get this BigTrak to connect to a Commodore 64 and be able to control it from the Commodore 64. What I didn't realise was, like most things printed in the 1980s, a lot of what this book is saying isn't correct and it will not work. So in this video, we're actually going to go through it and do it properly. So this time I'm using a different BigTrak to what I did in the previous video. That one, for some reason, the reverse isn't working on it. I need to look at that. This one we're just going to try it out as a normal BigTrak first. That's not good. So it's basically the battery compartment at the back is a little bit loose. As soon as I push that, it's working. So first thing I wanted to do was establish the pin voltages. So as you can see there, pin 16 is a plus 6 volts. Then on the 8 and 9 ground on that second chip. On the first chip it's pin 4. Now what I'm going to do is make this run forward, and I'm just going to see what turns off when this finished running. So I can see that pin there looks like is the thing that's controlling it. So now I'm just going to short it out with a bit of wire just to make sure I've got the correct connection. Yep, and that does make that wheel turn forwards, the right hand wheel. So again, I thought I'd do a quick little drawing here just so I don't get confused. Mark it up left hand side, right hand side. So that was right hand side forward, and that was pin 12 on that second chip. So do the same thing again, but this time I'm looking for the left hand side wheel forward. And again, testing it, I can work out that is the correct one there. So that's left hand side forward. So now I'm going to program the BigTrak to go in reverse, find out what my reverse signals are. So again, just try and test it. At this point, this wire just seems to just be a bit too awkward, so I thought I'd use a trusty pair of pliers, and obviously being very careful with this to make sure I'm touching the right pins. So that's my right hand side reverse. Yeah, so all I'm doing is touching it between the 6 volts and that pin just to simulate an output. And again, that's my last one. Now this is my left hand side reverse. So now I know what pins I need to go to simulate forward and reverse on each one of the driving wheels. I'm just making a note of it on this sheet. So as you can see, that's my right hand side forward, right hand back, 2 grounds, left hand side, right hand side backwards, and my other ground. So that's it. The next stage now is to test it on the computer itself. So last time I was using a tape drive, that tape drive has since died on me, so I thought I'd use my 1541, which is a bit quicker anyway to save programs. When you're saving to a Commodore 64 floppy disk, you just got to make sure you put your name in and then put .8. If you had multiple drives, first drive would be .8, .1, second drive would be .8, .2, etc. because there's only one drive on here, I could just do that. Just type new in there, so that basically clears all the memory list, and as you can see, nothing comes up. So now I'm just going to load that program in that I just saved, and then list again, and it should all be up there. Run it. Now this program's running currently at the moment, and as you can see on my user port, all my outputs I'm getting 5 volts. So right now I thought I would stop the program, because on my user port, whichever pin I go to, I'm getting 5 volts, except for the 2 M pins, which are 9 volts AC, but all the other pins are just giving me a constant 5 volts. If I use this as it currently stands, plugged it into my BigTrak, obviously I'd be getting 2 signals to tell it to go forward, 2 signals to tell it to go back at the same time. The other thing I realised is on that book it said about using pins 0 to 6 or 1 to 6, and I think I've done it to the wrong side. So what I did, I'm now using the PB0 to PB3. Just thought I'd try it out on another Commodore 64. As you can see, this one I've put a tag it at some point to say it's not working, which isn't 100% true, to be fair. What happens is you turn it on the first time, you get a blank screen. Turn it off and turn it back on again. If you just look at the top screen, you'll see a little blue from the TV. So it does work. It's obviously some kind of capacitor issue that I need to address. Yeah, so again on this one I'm just getting 5 volts again on all my pins. So it looks like this is a standard thing for a Commodore 64. When you first switch it on your user port, everything's set to high, so every single pin is set as a 5 volt output or a 9 volt AC output. So just again, I thought I'd try it on my Commodore 64C, exactly the same thing. So we can establish that pretty much any Commodore 64 on the user port is going to have all the pins high initially. What I decided to do, you can see I've modified the wiring now, so that's going to do PB0 to PB3, and I'm just using LED lights rather than connect it to the BigTrak, just so we can test it out a little bit better. And as you can see, before they were on the top, on my old video there, they're on the bottom. As you can see, when I initially turn the computer on, all the lights light up, the LED lights. Now when I first ran this program, like basically all the lights were staying lit up, nothing was happening. So when I looked at the book again, I noticed on another bit of the program that they did for something slightly different, they used 56579, and I think this is a mistake in the book here. This should be 56579. So if we look through the program, we start off with lines 10 and line 20. These are just REM statements. So REM statements are basically just comments. The computer ignores them. If they're in there or they're not in there, doesn't make any difference to the computer. It just makes a difference to somebody who's looking at the program, just to kind of see what the program's actually doing, and an explanation basically of what's going on. So the next line, line 30, this is the one that we've changed. So we're setting the variable PRT to 56577, and then we are poking 56579.255. Now that 56579 is basically now telling the user port that you're going to be acting as outputs. So if I change that poke to 56579,0, I believe that sets it to all inputs. So obviously we want it as outputs because we're sending a signal out to our BigTrak, not receiving a signal in from the BigTrak. And again, the 255 means I'm addressing every single, basically I'm telling it every single output on that user port I want to be active. So PB0 to PB7 are all set as outputs now. This PRT 56577, this is now to actually address individual outputs on that user port. So line 40, again we're just setting up some variables here. So we're setting up a variable KP with 197. Now this is the memory address that holds the current keyboard press. So again, depending on what key is pressed, depends on what number will be stored here. But right now we're just setting it up as a variable with that number. So now we're setting up variable FK for forward key with 22, and 22 is a decimal value for the T key. Next variable is BK for backwards key. We're setting up with 31, which is the decimal value for the V key. L key, left key, 21 for F key, and RK, right key. We're setting up with a variable 26 for the G key or the right. So when you press the right hand key, it basically puts that value there, so it's got something to check against, which we'll see later on in the program. Line 50 here, we're setting up variables for our actual outputs to PB0 to PB3, what we want them to do. So for example, first one here, SP0 is basically just going to set all the outputs to 0. FW9 is going to set PB0 and PB3 to high or 5 volts or 1. And again, BW, we're going to set that to 6, which is then going to set PB1 and PB2 high. LT, we're going to set to 10, which is going to set PB1 and PB3 high. And then RT equals 5, which is going to set PB0 and PB2 high. So if we go to line 60 here, we can see we've got SC equals peak KP. So what that KP is, was that address 197. So what we could do, if we didn't want to use a variable, we could have just put 197 in here. So what this will do, this will read, when line 60 is called, it will read whatever variable is stored in address 197. And then we're going to use if statements to check to see whether it matches any of the keys that we want it to match, or if no keys are pressed at all. So I did this chart here just to give a better understanding of how the PB0 to PB7 are addressed. We're addressing them in decimal. So with an 8-bit computer, the highest number you can represent is 255. So we look at our first one here. To turn on PB0 to PB7, basically we add all them numbers up together. So as you can see, PB7's got 128 above it, PB6 is 64, PB5 is 32, 16, 8, 4, 2, 1. So adding all them together makes 255. So if we sent a poke command 56577, basically means it's going to turn PB0 to PB7 all high. They're all going to go to 5 volts. Likewise, if we send a poke 56577, 0, it will set them all low, so it will set them all to 0 volts. So then, obviously, if we want to do a variation of it, we don't necessarily want to turn them all on and all off. We can now just pick our numbers out above the various PB and then do it that way. So for example, if I want to do PB0 and PB3, so if we look at the chart, we can see PB0 has a 1 above it, PB3 has an 8 above it, so 8 plus 1 equals 9, so we would do poke 56577, 9. And as you can see, with the way the numbers are set out, there is no other way to achieve 9. We couldn't add, for example, if we try to do it with PB2, PB1 and PB0, that would only come up to a total of 7, wouldn't work. So this is how the computer knows what outputs you're trying to address, because it is a unique address. There's no way you can represent that number any other way. Say we just want to turn on one output, for example PB2. As we can see on the chart there, PB2 is 4, so if we just did a poke 56577, 4, then it will just turn that one output high, and etc. So again, say you've got 8 different outputs or inputs depending on how you've addressed it with the 56579 initially, but in our case we're using them as outputs. Line 70, if SC equals FK, then poke print, comma, FW. So if we break this down, if address 197 holds the value of 22, which is the same as the forward key, then poke 56577 and give it the decimal address of 9, which is the equivalent of turning on PB0 and PB3, basically the 2 forward commands. And then if we go to line 80, similar sort of thing, but now it's backwards. So this will look for 6 and it will turn on PB1 and PB2 to send the BigTrak backwards. And then line 90 is 10, so that will turn it, or turn 1 wheel forward, 1 wheel back. And then line 100, this will look for the G key being pressed, and if that's pressed, then it will turn on PB0 and PB2 to turn it right. Line 110, if no keys pressed at all, then the input in SC will be 64, which basically means no keys being pressed, and then it will send a 0, so it will set all the values to low, so no outputs at all. And because this is a basic program, it basically does it line by line. When it gets to line 120, line 120 tells it to go to line 60, which is the start of that peak again, peak 197. So basically get what number stored in 197, and now we'll compare it against the various if statements and see if any of them match, and if they do, turn on the relevant outputs, and if nothing matches, then set it to 0, so all the outputs are set low. So that's our program. Now if I run it, the first thing we'll see, because no keys are pressed, all the LEDs are off. As soon as I press T, we get 2 outputs activated, left and right, and as you can see, all the various combinations reversed there, so that's working correctly. So now that program is looking good. We're just going to save it, and I'm going to save this as BigTrak 79 because of the 56579 statement being added to it. Now that's all good. So just bear in mind, obviously when we switch it off and switch it back on again, the computer, obviously all the outputs instantly come high again, back to 5 volts. So as I say, this is a new BigTrak, not the one I used in the previous video. Wired up, put all the wires into place now, and we know that these wires are going to the correct chip pins to give us the correct output we need. And also, as you can see, now it's in colour, it's a lot easier to see where everything is actually going on the board. And this is our user port wired up, and as you can see now, before I was on them top pins, now I'm on the A, B, C, D pins at the bottom. So again, just bear in mind, until I run the program, the BigTrak has to stay off, otherwise it's going to be sending a signal telling it to go forward and back at the same time, which is not ideal. So again, just checking to make sure this is all working the way it should be working, and it all looks fine. As you can see, my left turn, my right turn, and the backwards. It's working so well that that wheel looks like it wants to come off. All good. Just going to desolder this speaker cable because BigTrak as default because it uses 4 D-cell batteries and a PP3 battery, it has this annoying bleep that it'll do every 15 seconds to let you know that you're still switched on and you are burning your batteries, which again obviously is a good idea because then batteries aren't cheap. I mean, I'm using rechargeables in this for the main batteries, but still it's a pain if you've got to charge them just because you've accidentally left it on. The only downside to me doing this now is obviously if I use it as a normal BigTrak, which you can do with this mod, it just means that I can't hear the beep of the keypad, so I don't know whether I've pressed the keys correctly or not. But for now, I just thought I'd leave it because every 15 seconds with this, even though it's moving, because the instructions aren't coming from the keypad, it will just keep beeping continuously. So just putting the 6 screws back in the bottom here again, and then just get these 2 screws in the top. And so what I've done is, well, where the little port goes for connecting up your trailer and things like that, that's now just sitting in the front of BigTrak. I'm just using that hole rather than drill a new hole for it. I'm just using that hole for now, just for the umbilical cord. So just put all this back together again. Connect the PP3 battery. Now, case putting these wheels back on. So just remember, front wheel and back wheel are loose. They don't do anything. They're just passive wheels. The middle wheels have that little slot in them. And as you can see on the shaft there, so they're the powered wheels. So just make sure you get them. Well, you wouldn't be able to put, you could put the slotted wheel on one of the free rolling wheels, but vice versa, you couldn't put one of them wheels onto that middle slot. Just putting the bar across to hold them all in place. Just doing the same on the other side. Just change the battery thing for the other one that I cleaned. Again, just going to give this a test. As you can hear, obviously there's no sound now from the keypad, but it is working. First thing I remember with BigTrak is you can't run it on a soft surface. As you can see, it doesn't like it. Well, that works well. So I just put some hardball down here. And as you can see, it's actually quite responsive, surprisingly. The latency is very low on it from pressing the keys to the actual action. One thing I would do going forward would probably be do a wireless version of this though, because as you can see, if you maneuver the wrong way, this umbilical cord can so easily get caught under the wheels. I mean, also we're using 4 outputs. Potentially we could have an input for our little light emitting sensor, which actually tells you the position of the wheels on there. Plus also we've got our little laser beam on the front there that we could use to activate it. But for now, I'm happy with this. It's actually working the way I was expecting it to work. So for now, I think that's good. I'll see you in the next one.